Good morning to all of you. Myself, Dr. D T Tayde, Assistant Professor and Head, Department of Chemistry, Mahanta Jamnadas Maharaj, Arts, Commerce and Science College, Karanjadi. I am going to present my one of the research article, Mixed Metal Oxide Utilized for Synthesis of P-type Semiconducting Material, in your second international virtual conference on current scenario in chemical sciences. Aim and design of multifunctional catalyst. The catalyst should have acid-base property. That's why we select cerium and cesium. Copper is having a redox in nature. That's why we select the copper. And the electronegativity concept is used to designing of our multifunctional catalyst. Larger is the electronegativity difference between metal and oxygen, greater is the charge polarization, better will be catalytic reactivity. Here in this table, you see the electronegativity of copper and oxygen, electronegativity difference between copper and oxygen, cesium and oxygen, and cerium and oxygen. That's why we select copper, cesium and cerium metals for the synthesis of multifunctional catalyst. Experimental. In the synthesis of pure metal oxide, we take a salt of metal oxides, in nitrate salt of metal oxide. After that, add CTAB as a structural directing agent and ammonia, aqueous ammonia, for the precipitation of that metal salt. After the precipitation, we washed with this material precipitate with distilled water and drying at 100 degrees Celsius. After the drying, calcine this material at 500 degrees Celsius to get a powder form of metal oxides. After the synthesis of pure metal oxides, then we synthesize the series of cerium dioxide, cesium 2 oxide and copper oxide metal oxide. In this preparation, we take the nitrate salt of cerium, cesium, and copper. These salts are dissolved in distilled water. After the dissolving, the transparent solution is prepared. After the preparation of transparent solution, mix these three mixtures into one beaker with constant stirring and add CTAB as a structural directing agent. After the adding, we add ammonium hydrate for the precipitation of these salts and ages at 60 degrees Celsius and filter and wash. After the drying, calcine this metal material at 500 degrees Celsius for 1 hour in autoclave and to obtain a powder form of ternary mixture of cerium, cesium and copper oxides. We have followed this procedure for the preparation of these eight different type of metal oxides and mixed metal oxides with molar ratio. After the preparation of mixed metal oxides, we characterize this material by XRD and obtain that pure cerium oxide is cubic in a phase, matches with JCPTS card number, cesium 2 oxide is hexagonal in phase and matches with JCPTS card number, and copper oxide is monoclinic in phase and matches with JCPTS card number. After the mixing of these pure metal oxides, to observe that in the XRD 111 plane is matches with the cerium oxide, 103 plane is matches with the cesium 2 oxide, and 002 is matches with plane matches with the copper oxide, and confirm that our mixed metal oxide material is consist of these three types of metal oxides. After that, we take a scanning electron microscopic analysis of our prepared catalytic material and observe that in this image, A cerium oxide is porous in nature, cesium-2 oxide is a globular agglomeration in nature, and copper oxide is rectangular in shape, and the mixed metal oxide is mesoporous in nature. Means our catalytic material is mesoporous in nature. After that, we take a EDS analysis of our synthesized material and observe that the amount of cerium is 21.90%, cesium is 10.53%, and copper is 50.41%, and oxygen is 17.16%, and confirm that our mixed metal oxide is consist of these four elements in their structure. After that, we take the FTIR analysis. In the FTIR analysis, the band observed for copper oxide band, for OH stretching bands, and for OH bending vibration. Hence, we confirm that our catalytic material is having a hydrogen, and hydrogen is responsible for the acidic catalytic activity. After that, for the checking the acidity of our catalytic material, we take the pyridine adsorption FTIR analysis. Here we observe that the 1650 centimeter inverse band is observed in our mixed metal oxides, and 1446 centimeter inverse is observed in our mixed metal oxide. These bands are indicate that our catalytic material is having a Bronsted acidic sites and Lewis acidic sites. After that, we take the bed surface area of our catalytic material and observe that 36.81 meter square per gram surface area and 16.90 nanometer in size. After the characterizing of our synthesized catalytic material, we try or we take do the applications of this synthesized material for the synthesis of 9,9,10,10 tetracyanonaphthoquinone dimethane. Here in this synthesis we take alpha naphthol. Alpha naphthol is reacted with SNO2 metal oxide in the presence of HCl and H2O2 by using acetonitrile as a solvent at acetonitrile as a short one reflux in 30 minutes to get a 55% yield to get the intermediate naphthalene 1,4 dione. After the obtaining the intermediate, we react this intermediate with 2 moles of 2 moles of malonitrile in the presence of ternary mixture of our mixed metal oxide in the presence of acetonitrile as a solvent, and reflux this mixture to get a final product at having which is having 85% yield. The application of this final product is organic electric this is act as a organic electric conducting material, charge transfer complex, and optical and magnetic properties. We study the effect of various solvent in the synth and SNO2 on the synthesis of naphthalene 1,4 dione. In the first step, we study the effect of solvents and observe that within 30 minutes we get the 55% yield by using SNO2. And after that, the role of various metal oxide for the synthesis of our final product, we try without catalyst and with a pure metal oxide. We observe that in without catalyst there is no product is observed. By using pure metal oxide, there is a yield is very less and which is not notable, but by using a ternary mixture of mixed metal oxide we obtain 85% yield. This is the NMR spectrum of our synthesized material. This is the FTIR spectrum of our synthesized material, and this is the mass spectrum of our synthesized material. We are thankful to Dr. M.K. Lande sir as my research guide, a professor and head Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, and our college principal and all teaching and non-teaching staff of MJM College, Karanjadi. Thank you for all my well wishers. Thank you.